Hello, everybody. My name is David Presley, and today I will be talking to you about my lab number one, constant velocity motion. Introduction to the lab. For this experiment, our hypothesis is, will an object maintain constant velocity under stable lab conditions? In order to understand our goals for this experiment, we have to look over the principles, which are the constant motion in the x direction and Newton's first and second law. We will learn about how to account for errors in experiments, how to use Tracker and GlowScript to track an object and predict future positions, and what forces act on mass when stationary and while in motion. Some of the equations that we'll be using in our experiment today are Newton's first law, or the conservation of velocity, Newton's second law, the velocity update formula, and the positional update formula. For the positional update equation, we will use V final plus V initial over 2 to get V average because we're dealing with constant forces. We can also use a kinematic equation for this experiment because our forces are constant. Some materials that you will need are a device to measure distance, an object with low rolling resistance, a flat surface, a laptop that can run Tracker and GlowScript, a TI-84, and an incredibly accurate mouse to measure your center of mass. On the left is our system. It is the focus of our experiment and will be subjugated to all the forces of our surroundings. The surroundings is everything else and will be exhibiting the forces on our system that we'll be examining in this experiment. Lab procedure. Here are the steps to the experiment that I conducted. This is our video uploaded into Tracker. Our data is on the right-hand side, and to make sure that you get the best calculations, make sure that your center of mass is directly in the center of your object, in this case, the wheel. Results and discussion questions. After uploading our video in the Tracker, we have some initial values to examine. Please notice that on the left-hand side, initial velocity was calculated with a calculator, and is the average of our velocity final plus the velocity initial of the first time check. On the right-hand side is all of our initial values plugged into GlowScript. Some important equations to remember for GlowScript are the velocity update formula and the position update formula, both of which were covered earlier in our experiment. For our experiment, velocity average can be calculated by having velocity final over velocity initial over 2. Another important aspect of coding in GlowScript is making sure that you have the iteration steps down. Here's an example of mine. Our FNet is 0, 0, 0 because we have no net forces, or in theory have no net forces, acting on our system. After setting up your GlowScript code, make sure to run a simulation. You should get something similar to what I have on this slide, where position versus time is increasing at a constant rate, but velocity versus time is constant throughout your experiment. Here are the visual results of our inputs in the GlowScript. On the left, you can see that the ball has moved left of where origin is because we moved our wheel from right to left. And on the right, that is our data entered into GlowScript and our data for the experiment. There is a severe deviation between the two because the experimental data is subject to real-world forces. An important part of this experiment is the velocity results. As you can see, our initial and final velocities are different, meaning that an external force acted on our system, meaning that velocity was not conserved. A big conclusion from this experiment is that as time went on, my experiment data became less consistent with the X GlowScript data. This is likely due to external forces affecting X experiment, which changed the velocity and differed the slope in comparison to X experiment. Some major errors in my experiment is that we did not consider the Y component of X experiment at all, which was ignored. External forces like friction, sliding, and air resistance that likely affected the velocity of the wheel were also not calculated. An uneven floor also could have added more momentum to X experiment, hence explaining the higher values. And we also rolled our object from right to left, which gave us negative position values, which had to be corrected for in our equations. In addition, our center of mass was calculated by repeatedly clicking on the center of the wheel as it moved across our video, which is highly inaccurate. In our discussion questions, we were asked what would happen if the axes were flipped. Ironically, my values would stay exactly the same because we rolled our wheel from right to left, meaning that we already had negative position values. So altering the axes here would not have any effect on our overall calculations. Our other question was, could we calculate or even talk about how many other forces were calculated on our system? And the answer to that is firmly no. While we know that normal force and gravitational force did cancel each other out, there are so many other forces and factors at play in the real world that it would almost be impossible to calculate F net in our experiments. Thank you for watching, and good luck with your experiment.